So there are two things about Hess's law, right? Two things in chapter 10 that you need to concern yourself on. Both are called Hess's law because they're both about going to indirectly, a pathway that you can't go directly, you go indirectly on. They're both about this concept. Okay? So therefore they're both called Hess's law. The first way is algebraically, which means that we take all of the expressions and what do we do with them? Rearrange them. How so? What might we do to rearrange? We might flip IP, we might multiply, and then we definitely add them all up to get our final answer. Right? If we flip the reaction, we must flip the, yes, the delta H value. So if it was positive or negative, we have to change it. If we multiply the reaction times 3, what would we need to do to delta H? Times that by 3 as well. And then when we add, we end up canceling left and right. Canceling compounds. So that we end up with a net equation. This is not very, I don't like this pen. We'll figure it out. Okay, everybody remember algebraically? Mm-hmm. And I think we all decided at the end of last week that we knew what we were doing, but we needed more practice on these so that they became faster and more comfortable for us. Are we still feeling the same way? Yeah. Mm-hmm. Okay, so new page. Number 2 then. We will do practice on those today. Number 2, the second way of Hess's law is solving for delta H, not algebraically, but rather using the equations. What are those equations? Formations. So the delta H in standard conditions, what was standard mean again? SATP, which means what? You got to know these. Room temperature, what degree Celsius is that? 25 degrees Celsius. What about pressure? 1 atm. And what about concentration? 1 mole. 1 mole per liter. Okay. So, in order to figure a reaction out that's happening at standard ambient temperature and pressure, we can do this funny, crazy equation, which means the sum of the number of moles of the delta H naught formations of the products minus the sum of the number of moles of the delta H naught formation of the reactants. My pen light keeps coming off. Right. First of all, products are on the right-hand side of the arrow. That's something that students muddle up all the time. I'm not sure why. So when you're having an equation, it's always reactants go to products. Products are produced, reactants react. Some people just don't seem to be able to get those straight in their head unless they really stop and think about it. If you are that kind of person, that's just a natural thing about you, and you should always, over top of your equation, C plus D, write R, oh, see I just did it, write P and write R so that you get them right, because some of us confuse them all the time. Okay, so products are the ones on the right hand side. Where do you get their delta H values from? Where? The data booklet. And what is the N for? Right, the balanced numbers. Okay? And where do we, and then same thing on this side. But of course that's for the things on the left. What do you need to remember about the delta H naught F for elements? 0. It's 0. Because you don't form an element.
1.
Pardon? Okay.
What is that?
So, for example, if I had, what is the delta H, the question is, what is the delta H naught for the combustion reaction? That's the question. Of CH4 plus O2 goes to CO2 plus H2O. First thing I'd want to do is balance it. So a big 2 there, and a big 2 there. Okay? So then, and that's all the information they give me. I don't have any equations to cancel out. So therefore I have to use Hess's law of this. So delta H naught for the combustion equals the sum of the this and this and this. And I'm not going to write it all down again. So I first do the products. So that's these. So, and they'll be gas products. So I look up in my data booklet, making sure I'm paying attention to the gas because there's water liquid and water gas. So, square brackets. It's very important you type this in your calculator properly. You look up delta H for your carbon dioxide and water, and what is it? Somebody help me.
It's
Negative 200 and
41.
oh, in fact, you know what? I'm just going to hold that out. Communication. Okay, because there's a 1 here. Are you talking about water?
Yeah.
Okay, so 2 in front of the water, so therefore it's 2 times. What is the delta H for water?
Negative
Gas, water vapor, I should say.
Negative 241.8.
Kilojoules per mole. And you know that this is 2 moles, right? So the moles end up canceling out, and then I'm left with just kilojoules. Plus 1 times. What is the delta H naught F for carbon dioxide?
Negative 393.5.
Okay? So that was just this. That's all I've done so far. Okay? Subtract. Square brackets. This side now. Methane. 1 mole of methane times, what is the formation of methane?
Negative 74.6.
Plus, what's the formation of oxygen? 0, because it's an element. Play along, as opposed to 5 steps behind. Oops. Undo, yeah. Good. Okay. You know, this is so hard to write on. I'm going to figure out what I'm doing wrong. Okay. And then tappity tap tap in your calculator, and you find what? The delta H value. Which should be about 1,000 something. Oh, and should it be exothermic or endothermic? It should be exothermic. Why?
Because the products are more stable.
How do you know that? Even faster.
Negative.
What are you doing? What's the reaction?
Breaking it up.
Combusting. You're burning methane. Is that not going to give off energy? Yeah. So my delta H better be negative value when I'm finished. Tappity tap tap, you should get a negative answer anyway, but you never know. Okay? What did you get?
I got negative
800 and?
802.5.
2. Oh. One day. 802.5 kilojoules per mole is our final answer. Okay? The hardest part about this is putting it in your calculator. Oops, I mean this. Okay, we're done. Now, what you're going to do, and actually I should leave this in the recording, what you're going to do is I have a sheet for you which has first of all practice on delta H algebraically, then practice on delta H formations. So Hess's law part 1, then Hess's law part 2, then they all mix up. So you need to kind of figure out which one you're supposed to use. Okay? And that should take us to the end of class, really, is probably that.
Yeah.